Right, hello and welcome. This is a Edexcel C3 video on, well, it's not covering the whole topic, it's just covering part of a topic, and this is on the differentiation of basic trigonometry. Now, in my last video I tried to find a question that had multiple rules in it. Just looking behind me, there's a few examples, and not necessarily the rules, but bits of information that are quite key to know. I have found a question that has multiple rules in it, to be precise, of how you differentiate it, and I'll explain a bit that in a minute. So I'll just rub this off. If you didn't get this, I did do it in my last video, which was the actual differentiating basic trigonometric equations, etc. This is just sort of recapping it in a way, and just sort of going over a question that I've just seen. I've just done it myself, so hopefully I won't have to worry about for too long with this one. Okay, so if you're in my class, starting to do this a bit more regularly, if you go to your C3 book and question some context in it. Sorry, just give me a second. Yeah, so if you go to exercise 6.2 question 4, is it? Oh, sorry, question. Question, damn it, no copied the question down correctly unless I'm missing it, sorry. Alright, well, what I've done here, what I've done is, for you people who are wondering what I'm going on about, I've used question 4 in our C3 booklet with the people it will make a difference. I've used the equation from question 4 and I've put it in question 3. That's why I was getting confused there. Okay, so in my mind the question said, you're given the function fx, and this is the function from question 4, so 4x cot x. I don't see why this wouldn't work. It was working when I was doing it. Worked when I did it. So that's 4x times cot x, and it says find the gradient of the curve of that where x equals 0. And now the first thing you need to remember, this is C1 knowledge, the gradient of the curve, so dy by dx equals the gradient function. So that's what, so obviously that is going to equal 0. So when we do the derivative of that, it's going to equal 0. However, before we continue, cot x. What is cot x? Well, if you look in your formula book, cot x, I did explain this in a previous video, but for those people who don't really care, is 1 over tan x. And I can prove that to you. Because, as we all know, tan x is sin x over cos x. And 1 over everything is something is a reciprocal of that, so we flip the fraction. So instead of your normal sin x over cos x, it becomes cos x over sin x. So we can do that. So cos x over sin x. And we can rewrite this function here just with that. We've not changed it, we've just changed the way it looks. We've not changed the mathematics behind it. So 4x times, instead of cot x, it's the same as saying cos x over sin x. So that's what we've done. Okay, so that's our new function. It's the same as the old one, just looks slightly different. Bit like, well, if this was more of a topical video, I'd say something else. Obviously I can't say that. Okay, so what rule are we going to use? What rules do we know? Two functions of x there, and we are differentiating them. Okay, so when you differentiate them, if you've got two functions, the one function you normally use is the product rule. I think it's called, where you do one of them times the differential of the other plus the the other, vice versa, to the other way around for the other one. So basically the differential of 4x times cos x over sin x and the differential of cos x over sin x times 4. Hopefully that makes some kind of sense. Right, so first thing we need to do, okay, so we need to write down what vu dv by dx and du by dx is. So it doesn't really matter which way you choose it round on this one, but I generally have the v being in front. Okay, so v equals 4x, u equals cos x over sin x. The 4x, so dv by dx, 4 times the power 1 is 4, take away 1 power from x to the power 1 equals x to the power 0, which is 1, and that just leaves us 4. Du by dx, however, is not quite as simple as that, because what we have to do for this is we have to bring down our old friend, the bracket rule. The quotient rule, sorry. So that's the quotient rule, says y equals u over v. And in this instance, we've got u as being cos x and v as being sin x. And you should know from your basic trigonometric functions, du by dx for cos x, so cos x goes minus sin x, and dv by dx, so the differential of sin x is positive cos x. So that's what we've got there, okay? So, what can we do with that? So it's sort of doing a differential inside of a differential, essentially. So essentially what we're doing here. So, what we can do here is, we've got our original equation, we've got the bits of information we need to know, and we need to differentiate that. Okay, so how do we differentiate this? Well, we do the original differentiation that we're going to do for this equation, so the main equation, and we're going to differentiate it purely for that one part. And now the only reason I'm doing this is because we've got all the information we need. So when we differentiate the cos x over sin x, we've got the differential of v. That's not the whole differential of the whole equation, that's just the differential of v when we differentiate this. But we need u and v inside that, if that makes any sense. Okay, so what we've got here. So to differentiate cos x over sin x, so dy by dx, do the same thing. So we've got u and v here, so v, so we do sin x times the differential of cos x, which is minus sin x, plus the cos x times the differential of sin x, which is positive cos x, and we can simplify that down. So dy by dx equals minus sine squared x plus cos squared x. So the differential of cos x over sin x is minus sine squared x plus cos squared x, and we've just used the bracket rule for that. So hopefully that makes some kind of logical sense. So we can go back to our original headache of 4x times cos x over sin x, and we still need to do the differential of the whole thing there and make that equal to 0, which all we've done so far is done the differential of the second part of the original equation. Okay, so obviously we could simplify that down, and I think minus, and yeah, actually we'll do that now. So differential of this, we know, is minus sin x plus cos x, so minus sine squared x plus cos squared x. Now if you cast your mind back to C2, one of the trigonometric identities that we looked at was 1 equals cos squared x plus sine squared x, so we can rearrange that. So 1 equals sine squared x plus cos squared x. Okay, so what the best thing to do here in this situation is make I guess you could rearrange that. Should have thought about this. I didn't get this far when I was doing the question, so this might not work out. What would you do there? Okay, so you could make so cos squared x equals 1 take sine squared x. Or you could change that to cos x. Oh, sorry, you could change that to sine squared x. So in that case, sine squared x would be 1 take cos squared x. So you could do it either way. So you could change sine x. So our derivative of cos x over sine x is equal to minus sine squared x plus cos squared x. And then we could simplify that down by changing minus sine squared x to cos squared x take 1. Or we could do it the other way. Now I'm thinking we should change it to minus sine squared x. Now the only problem with this one is it's positive sine squared x is 1 take cos squared x. So what we'd simply do is times the whole both sides by minus 1. So that gets minus sine squared x equals so minus times 1 is minus 1, and minus 1 times minus cos x is positive cos x squared, so we could simply do cos squared x take 1. And then we put that back into the original derivative. So of cos squared x, it was originally minus sine squared x plus cos squared x. And we use the trigonometric identity 1 equals sine squared x plus cos squared x to get us the minus sine squared x. So we can put it into the derivative of cos x over sine x. So we can make that equal to so that would equal, so dy dx of cos x over sine x, we could make that equal to cos squared x take 1 plus cos squared x. And then if we did that, that would mean we got 2 cos squared x, so we do 2 cos squared x take 1. So that would be the derivative of cos x over sine x. Now I feel I'm running out of room here. So if I'm just going to tidy this up a little bit and then I'll go through again what we've done. So just to give myself a bit more space. So I'll put that cot x up here. 1 over times. So, sorry, just let me remember, it was cos x over sine x. So, sorry about that. So, as we were saying, on this part of the equation here, we've simplified it down so that the differential of cos x over sine x is the same as 2 cos squared x take 1. Okay, so originally back to our equation. So that's 2 cos squared x take 1 is the derivative of cos x over sine x. And we prove that by this strenuous equation here. Okay, so this is our original equation. We want to differentiate that by doing what we just did here, but to the whole equation. That was just for one part, half the equation. So dy by dx equals, and we've got our v, so 4x times the differential of u, which is cot x, which is what we said here, which is cos 2 cos squared x take 1, plus the cot x. So we could just simply write cot x if we want to make it simpler instead of writing cos x over sine x, and then we times that. So we actually, instead of writing cot x, well, we could write cot x actually, and we times that by the derivative of 4x, which is just 4. So that gets us our original derivative of 8x cos squared x take 4x, is it? Sorry, I'm getting confused here. Yeah, this is probably a little bit intense. Sorry, should have thought of this. So we'll ignore that. So 4 cot x. So we've got here for the derivative of 8. I think 4x times 2 squared cos x, cos squared x, take 1. I think we should multiply the 4x by the minus 1, so that gets us minus 4x as well. Okay, so what we've got here is a derivative of fx is of 4x times cot x is 8x cos squared x, take 4x plus 4 cot x. So obviously that has to be equal to 0. And I'm not really going to have enough room here. So 0 equals 8 cos squared x plus 4x, sorry, take 4x plus 4 cot x. Shouldn't have taken up so much room with the board. Right, sorry about this, guys. So 0 equals 8x cos squared x, take 4x plus 4 cot x. And now that 4 cot x, I'm going to change it to 4 over tan x. Let's do that, it's a bit simpler. Okay, so what you do from there is you'd find what x is, and it's asking. Oh, damn it. Oh wait, what's it saying? Sorry. It says find the gradient of the curve where x equals 0. Oh yeah, so sorry, I've done that the wrong way around. It is doable. So what I was doing there, I got myself a bit confused. I was thinking, find the point on the curve where the gradient is 0. What we're actually finding is find the gradient on the curve when x is 0. So all we're essentially doing now for that dy by dx is putting x equals 0, sorry, into that equation. So it's 8 times 0 cos squared times 0, take 4 times 0 plus 4 over tan to the tan x, which is 0, over 0. So if we do that in our calculators, so 8 times 0, I'm feeling this might be 0, times cos I'm sure there's an identity I'm missing out here. Right, well, I think I'm a little bit stuffed on that. So anyway, that's what you do. You put x into that equation there, and that dy by dx, that last one, and that would get you your gradient at the point x equals 0, which I think is most likely going to be 0 by the looks of it. So unless I've done that wrong, I don't think I have. So anyway, put me a note in the comments if you think that's wrong, but I think that is quite correct. As long as you put 0 in there, I think you'd be quite good. What else to say? Yeah, I think that's all good. If you again, if you have any comments or anything, just let me know. Unless it's telling me to go and do something, then you know you can keep that one to yourself if you want to. Okay, so I think we'd definitely get most of the marks for doing that, working out. But since I messed up the end bit, and I think I should have changed cos squared x or something, which I'll probably remember after I've switched the camera off. Yeah, just let us know if there's anything that you think on that whiteboard that is incorrect. But thanks for watching, thanks for making it through, and we'll see you on the other side.